Okay. Hi, everyone. Hi, listeners. Unit 2. I am Dr. Gausia Banu, Associate Professor of Narasimha Reddy Engineering College, UJC, Autonomous Institute. So, there are few points to be discussed regarding the introduction to relational model. Actually, well, this is the basic funda and which I want to give you everything in brief. Relational model based on theoretical or mathematical model. It is a relational database. Concept is all about relations. Relations means connections based on sets. Model means representation. So, relational model was proposed by E.F. Codd, who was working in IBM in 1970. Model data in form of relations represented in tables. Relation model used for data storage, processing, etc. And all the alterations, manipulations, controlling transactions are all done on the relational model. After designing conceptual model of database used in ER diagram, it converts ER diagram to relational model, then implement on RDMS language like MySQL, SQL, Oracle, Sybase, Informatics, etc. RDMS stands for Relational Database Management System. This is basis for SQL for all database systems like DB2 and Informatics Dynamic Server by Oracle, RDB by Oracle, SQL Server, and MX Access by Microsoft. DB2 and Informatics Dynamic Server by IBM. Relational Database Management System, that is RDBMS, is a management system of data based on relational model and was introduced by E.C. Codd. Is a combination of theoretical and mathematical models. Relational model concepts are represented as tables called relations. Tables has columns and rows. Each row is called a tuple or record. Each column is called a attribute. Relation on table name, for example, a student table can have roll number, name, and phone number. So this column field is called attributes and the rows is called tuple or a record. The table is name is called the relational name. The domain is a set of allowable values for one or more attribute because, for example, phone number cannot be strings or greater than 10. Like this, some minimum constraints or restrictions are available. The values of each rows and column is called domain. Relational schema. Relational schema represents structure. Structure again is called schema. Name of the relation within its attributes. For example, student file has roll number, name, and phone number. So this is called the structure of student table or schema of student table. Instances state is a finite set of tuples. It do not have duplicates. Degree, the number of column or attribute or a field is called the degree. Cardinality, total number of rows and tuple and record is called cardinality. Relation key, every table has a unique key called the primary key, which is represented in ER diagram by the underline. Data storage in tuple variable. For example, a student table or a relation table, student relation table can have attributes, roll number, name, and phone number. Hmm. Next, the phone roll number can be a varchar or a integer, depends upon the data type inserted. Name is characters. Phone number is integer of the range 10. Every column has a domain. In that domain, we store range values. The range values has some limitation, constraints, restrictions, which is acceptable. For example, name should have characters. Phone number should have numbers, integers 0 to 9. So for every domain, they exist a proper range. So this is called fit ratio. If mismatch again occurs, that is called miss ratio. Tuples are also called rows as we have discussed. Relation schema, for example, student in the bracket, roll number, name and phone number, bracket close and semicolon. This is called schema. Next, relational instances. Value stored in relations is called relational instances. For example, for the values for cell number, the value it can be numbers exist from 1 to 10. Next, properties of relational model. Each relation or table has a unique name. Each row or tuple has a unique number. Duplicates are not allowed. Each column and attribute is unique. Entities are also exist in the table. Entities in column have some domain of same type, should be in integers, so and all in characters. Order of column and row can be of any order. Relations are an unordered. Every cell in the table has one value that is called atomic terminology. So the formal names, alternate name As let me tell you, relations are used in DBMS. The alternate name of relation is table, or it is also called file in file system. And tuple in a formal way, tuple, whereas in ordinary way it is called row, or and in file it is called a record. Attributes in a formal name, and that in the table it is called a column, and for a file in file system it is called a field. Introduction to relational model is as follows. Relational model, it is used for data storage and processing. Relational model is based on mathematical and theory concept which is represented physically in a table. A relation is in a table with columns and rows. Each column is called an attribute. The table or relation is a combination of rows and columns. The whole table can be have a name. The values of each column plus row is called domain. So the topic to be studied here is integrity constants over relations. Coming to integrity constant over relations. Relations means tables. It consists of values and it follows a set of rules and conditions. So these rules, conditions and restrictions are called constraints, means conditions and rules which should satisfy two protocols of the constant on the DBMS. Integrity constraints are used to ensure accuracy and consistency of the data in relational database. The integrity constant is a set of rules, protocols that database is not permitted to violate. The constants may apply to attribute and may apply to relationship between tables, relations, or files. Integrity constants ensure that changes like add, delete, update, insert on database by authorized users, which should be violate the protocols because not result in loss of data consistency. So accidentally, same is saved by integrity constraint. Blood group ABO, but does not have minus 0, 0, FGI. So this is violating the rule. So this is called the constraints. Types of integrity constraints as we have seen. Is domain constraint, entity integrity constraint, differential integrity constraint, and keys constraint. Domain constraints defines the domain. That means domain means valid set of allowable values in attribute. The data type of domain include string characters, integers, time, date, currency, etc. Values of attributes are put in the domain. CHAR function, that is bracket, is for characters. Varchar is for alphanumerics. Next, date is a reserved word for DDMMYY or MMDDYY. Next, int with brackets open and close is called a integer. Next, time is the reserved. Next, so in domain, if the attribute, they should not be any other foreign letters so that it violates the domain integrity constraint. In the same manner, entity integrity constant also has some constraints which should be followed to fulfill the integrity constraint. Same like referential and key constraint also. Enforcing integrity constant means to specify when the relation or a table create, modify, insert, delete or update, etc. action causes violation in the table. Here is that is rejected. When action is done on relation table, then only integrity constants come into the picture. In case of domain and a table, integrity constant, any changes done in the table is rejected. But in the case of referential integrity constant, care has to be taken because two or more tables exist where takes for one table it is taken as primary key and the same primary key is referred as foreign key for the next table. The different mechanisms is complicated. It does not reject or violate. It tries to rectify it automatically. So the key which is having primary key is called the referenced table, and the table which is having foreign key is called the referencing table. Suppose, suppose I want to insert null in primary, which is rejected. So this is one of the violation or restriction for the constraint. Next, if I try to insert some duplicate values, it also violates. Mechanisms on foreign key is not violation, it rectifies here. The key which is having foreign key, that is called referencing table. So here is the entity is weak. So insertion is a problem and deletion not a problem. Updation is also a problem. Next, in the primary key table called difference table, division is a problem. Insertion is not a problem. Updation is a problem. Cascading means the primary key of one table is cascaded as foreign key of the next table That is called referencing table. The, the, the table which consists foreign key, it is called a referencing table. The key which is having primary key, it is called reference table. So this table uh, the is cascading with the foreign table and so on. Multi-cascading tables can also be used with the help of defined protocols and some commands. Like references table student or students, on deletion cascade, on update no action. So when we are deleting the cascade, an updation is no action is there. The next is the query relational data. The query is nothing but a question to a database and get the answer which consists leads to the result. For example, we Google it with a query, we get the answers within minutes. So what is the database here is query relational database. Since structured query language in full form, this is one of the characteristics of relational database management language in commercial world. The logical database here, logics like and or not and some other logics is also used with the combination of and or and not. The ER diagram is like a blueprint for the relational database. From there, we can create the relations. From there, the queries start. So some of the things which we can follow is entity set to tables, relation set to tables. Next, translating relation set into key constraint, translating relation set to participation constraint, relationship with weak entity set, which is represented in a dark or block line with a weak entity of double rectangle and a double rhombus with a double arrow mark. Next, translating class hierarchies and follows the inheritance principle. The next is the aggregation. So this is a brief introduction of the part one of the introduction to relational model, like integrity constraint, enforcing integrity constraint, query relational data, logical database design. The next, we are going to the introduction of views. View is relational algebra. Okay, we have to go to the views. Views is, before going to the views, The enforcing integrity constant are specified when the relation table is created, modified, insert, deleted, updated, etc. action on relation table that is rejected when action is done on relation table. Then only integrity constant come into picture. In the case of domain integrity constant, any changes done in the table is rejected. But in the case of recursion integrated constant has to be taken because two tables exist. That is, one table has primary, which is being referenced to the other table of foreign key called referencing table. It does not reject or violate. It's tried to rectify it as we have seen it and heard. Next, coming to the introduction to views. Views is nothing but is a virtual table. Suppose a person want customer loan number. We will tell only the customer loan number, but we does not tell all the details related to the customer file, etc. The other details are hide from uh, other persons and displays only the customer loan number. So the other data is being hidden, and this is we seen in entirely logical model or entire database. So we are temporarily creating a table that is relation that is called virtual table only to show virtually. This is called views. Views show only few portion which is selected. Any relation that is made visible for the users are as virtual relation and is called a view. It provides limited access to database which presents the tailored schema. Views are virtual relations or virtual table through which selection portion of the data from one or more relations or tables can be seen. Virtual means do not have any physical existence. Two types of views are present: read-only view and updatable view. Read-only view can only affect on the master database, whereas updated view can have can affect the master database. Read-only view cannot affect the master database. So, so views is nothing but the virtual table, not exist reality. It is virtually. So for storing in database dictionary in table for further computational process, database and for viewing and presenting for the user, not stored, and it is separate. It is a virtual table. For examples, while doing in our lab, the concept like cookies resembles the views. So create view is the syntax with the view name, view table name. Okay. The next one is the uses of view for viewing for repeated tables, for storing complex queries, to restrict access to database for unauthorized viewers, to hide data complexity, can make multiple cascading views, can do add, delete, update, and modify the master table. Conditions for and condition or constraints on view can be used with the help of group by or order by clause is not used, so should not have distinct keywords. Nested complex queries are not created, does not have any null values, create simple tables, cannot use for multiple tables. So when the syntax create view with a view name as is being attached to the select statement from the student table. Create also means we are creating a view as from the select from the base table. So coming to drop is nothing like destroying or like delete. So allowing destroying the tables. After use, the table can be destroyed. So drop is the command to restrict the data or destroy the view table. Or alter should like add the columns or update. So view is a virtual table. So the contents matter in view table will not be any physical, but through view we can reference values in the table. View table are used by our view from the base table. We can define a view in SQL and PL commands very comfortably, and use in SQL also is a comfortable concept. Use advantages can hide data complexity like joins. You can use for security mechanism. No physical existence are present in the view. No record in the view. Only holds the definition of the table and fetches data from the table server. View is stored as permanent query object in database. That completes the introduction to this. Introduction to next coming to the relational algebra in 1970, given by E.S. Ford, father of DBMS, also called procedure of formal key. The reasons is we have to mention what to do and how to do, and we have to access data from remote areas, so that method is mentioned in relational algebra. Before SQL, we used relational algebra as a base to relational database management system. Some characters we have already seen in mathematics is projection is by pi, selection is by row, cascade product is by cross, union by u, rename by row, set difference by minus. In join, again derived operands like join, intersection, next division and multiplication, and next types of joins which are used in derived operations like multi-join, conditional outer join, and natural join. The inverted E represents there exist. V with in the middle of there is a line that is for all. So we have seen the formulas for domain relation calculus and tuple relation calculus. So I think you have understood the introduction part of this chapter.